I did want to talk about this little exercise. I asked you to earlier when we were going through Twitter information. We noted that when you're applying, in contrast to streaming, where you're giving each batch of tweets every so many seconds as a group, and you can use a dstream to access them. When we query the Twitter search API, we will get back tweets in a paged model. What do I mean by a paged model? Can anyone comment? What do I mean by the fact that it's a paged model?
We'll give you back the results in discrete pages.
Good. So we query, and like with a search query on the web, on Google or Bing or whatever service you use, you'll get back the results a batch at a time. So you'll see one group, and you can ask for more, and see another group, and ask for more yet, and see another. And this has several advantages. It doesn't speculatively give you all, the expectation you're going to need all. Maybe you only go the first page or two because you find something of interest. You don't need to go back further than that. Down to the first page would be the most recent, and then you can go back further. But maybe you don't need to. Second of all, it actually allows for some updating of contents on later pages, what have you. But, ladies and gentlemen, it makes it a little bit less pretty to process. So I asked you to try your hand at two different ways of creating this. One was an imperative style, and one is a recursive style. So the imperative style was one I actually fleshed out less completely. But basically what it involved was, in both cases, we're trying to go through the tweets that we received, and they both match the same interface. So we're going to get in a max number of desired tweets, a function to determine if a given tweet, as judged by its status, is interesting, and a query. What is this query? What is that query?
Well, it's one that you create, I guess.
Yeah, it's one that I've issued in order to get the tweets. And then this returns three things. Four things. What are the four things that it returns? Well, a tuple of the total number of tweets processed, a total number of interesting tweets found. So that's a subset. Total number of interesting tweets is less than or equal to total number of tweets processed. This is the total number. These are a sequence of those that are interesting, a sequence of their status. We've harvested them, and the earliest date encountered in any tweet as we perform the above. Okay, so how do we do that in an imperative style? Well, one thing we could do is we can have a variable. Okay, are there additional results to process? We basically loop through. We perform a search. We get the tweets in the search. Notice the take is defined. You could have something that includes 12 tweets and say take 20, and it'll still only give you 12. That's fine. So you're taking up to the number here. This is kind of our remaining tweets that we can get without exceeding our max desired tweets. And it's based on something itself as a variable. Count tweets received. These are the tweets that we've processed thus far. And we go and we get the number of tweets we have to process in this page. We get the minimum date processed from this page. This is the set of tweets in our page, and we get the size to tell us how many in this page. We get the minimum date to get that. We increase the total we've received by this number, and then we filter those tweets to only give us, well, what is this doing? What's this filter doing?
Well, it takes the status and then it looks to see
Yeah.
if it passes your interesting filter,
Okay, good.
and then if it does, it only returns back that status.
Good.
So presumably your
Yeah.
FN is interesting, returns something for a status that's not.
If it is interest, returns a Boolean. So remember, filter takes a function that returns a Boolean. And
Right.
and so it will filter out all that don't match this criteria, and then we're turning those that do match the criteria into a vector, right? Those are the ones there. And then what am I doing here? By the way, I'm incrementing the count of interesting tweets I've got. What am I doing here?
Concatenating that. To
Yeah,
the previous-
probably you can do this. I don't know, but basically I'm concatenating the ones I previously had with the ones to this page. I ask, okay, are there previous results to process? Well, there are, if we both have tweets that we're still seeking to process, and if there's a next page. And then we get the next query and we use that for the next round of querying. So we just go through here. Notice we're doing a number of things here. There's actually quite a bit of machinery. We're keeping track of running total of the counts received. Notice these vars, right? The count of interesting tweets received, we're incrementing that. Count of tweets processed, count of interesting ones processed. The minimum date, we're sort of successively updating. And then the minimum date processed thus far, we're updating. And then this, whether we have additional results to process. So there's a fair bit being mechanically updated each time through here. These things are basically changing over time. Okay? And at the end, as long as we have ones to process, we continue looping, and then we return here at the end this. And you notice, because of this appending, we're successively modifying that filtered tweets across all pages, the value associated with it. We're just appending it onto there and rebinding this. Okay.
I have a question.
Yes.
If you're modifying it,
Yes.
how is it a value? Instead of bar. Is it a memory thing or something?
That's an interesting thing. I was wondering that myself, but okay, let's try that. Here we go. Mumble. Paste. Okay, val foo 2.
I've tried it.
What does it do?
That.
Yeah.
Resign.
I think actually I haven't tried this out, so I think it would have to be that.
Okay.
Yeah. Okay. So there's a lot of moving parts, almost literally here. These things are updating. Let's check out the recursive version. Okay. Here satisfies the same specification, but it's how it does it is different. Okay, we get the results. Where's the loop? Where's the loop here? Eh? Where's the looping?
It's recursive. So
It's recursive, ladies and gentlemen. And so it's calling itself here, where? Right there. Right there. And there are no vars here. Not a single var. So it's getting the results. It's getting the tweets in page to process. These are the tweets. It's getting the tweets processed to this page. It's getting the interesting tweets and the count of interesting tweets. It's printing them out. And then what happens? Well, it figures out, is there a next page to process? If there's no next page to process, what do we do?
I guess you're done.
Well, yeah, we just return the number processed this page across all of these things and the minimum date in this page, and we're done. Now, does this immediately return to the original caller of this? No, it returns to the previous, or this thing called itself a lot of the time. If we have more pages to do, what we do is we handle them, and then we simply return values which take the values from them and add them to the values for this page. So this is the count of tweets processed in later pages. So it's divide and conquer, ladies and gentlemen. We're calling successive pages, getting them to be done, and having done that, we just add them to our page and return those as the results, the cumulative results going back from our page, okay? And notice, like this earlier date process, that's from the later page. We just throw out ours. If there's a later page to process, we know that must be earlier, so we just ignore ours here. Otherwise, we're sort of accumulating here. This is an append, but there's no var here. Why aren't there vars, folks?
Because they're only being created once. And then
They're only being created once,
there's
yeah.
like 8 result values that are being created.
That's right. That's right. So it's just accumulating, coming back, ladies and gentlemen. It's going, processing each page, which is the actual, well, yeah, so the first page is processed, it calls, and then it processes the second page, processes the third page, processes the fourth page. But those aren't finished yet. Those are still active. It's calling each successive page. And then when it gets to the final page, it's going to start returning. And those earlier pages will take the results returned, add them to their own results, or prefer them to their own results, and return from there, return from there, return from there, all the way back to the beginning. Now, I don't know, for those in the room, how comfortable you feel with this. I don't know which you feel is recommended by greater beauty. I don't know which you feel is more understandable. But if you are not understanding this code, please study it, because this gets to the heart of functional programming to solve things through recursive decomposition. And this is a nice little case study of how recursive processing works. This has a certain logical sense to it that is, I think, familiar to anyone in this room. This idea that we have these running counts and we're adding to them. This, to me, is actually prettier. much more beautiful. There's no moving parts. There is simply beauty. No, that's not quite true. There's no moving parts, but
There's changeless, stateless beauty.
That's right. It sort of has a platonic beauty to it that is striking. So we're decomposing this thing. We don't have to worry about updating a variable. We're simply solving each subpart and then combining those solutions. There's no, don't look now, we're going to update this, and now it's changed, and when was the last time it was updated? We simply have each component processing its own in accumulation. In many ways, this is quite similar conceptually to map and reduce, in the sense that we're handling each page, and then we are combining the results of each page to become larger and larger aggregate, and combining them together in a way that yields us the total results. Now, some of you may wonder, is this going to cause a problem? What problem are recursive solutions sometimes associated with? Memory. And why is that?
Because each recursion causes a whole other function to happen, and if it's holding
a new activation record.
Yeah.
And that could be a problem if you've got thousands and thousands of pages, for example. Mm-hmm. There's actually a way that you can transform this by, and actually in that functional programming in Java book, it gives examples where basically we end up putting the accumulation into the parameters pass, and then you turn it to what's called a tail recursive function, and it can get passed automatically. I think within your professional lifetimes, and maybe right now even for some compilers, that type of transformation could take place automatically by the compiler. There's a potential for it to just take care of it. So this issue of a Stack Overflow, my advice to you professionally would be don't worry about that as a structural barrier. That's going to be dealt with. And I'm tempted to go into a soliloquy. One might say into a tirade. One say into a Jeremiad about the number of times that professionals have compromised the clarity of code in a misbegotten sense that they need to make it more efficient. They need to compromise it, and actually they're operating off of myths, and they're ending up compromising the flexibility of their code for the sake of a misbegotten notion that somehow it's going to be less efficient, where often that's just not the case. We'll see that for those taking 470 next term, that often students have this mistaken notion that things are really inefficient, but you actually look at the timings, you actually look to what it compiles to, you use a profiler on it, and it's actually much less a problem than you might think. So recursion, ladies and gentlemen, I urge you, I inveigh upon you, I invoke to you the desire for you to embrace it, to use it to good effect. And I think this is a case where, in my mind, it improves the quality of the code. Too long has software engineering, particularly in North America, been subject to a mediocrity of expectations, where good has become the enemy of great. And finally, functional programming is being given its due. Don't allow, ungrounded fears about performance to dissuade you from embracing it. It can offer great clarity and power. And so, if you're not comfortable with this, please study it, and I will be glad to tutor you on it to help you fully understand this recursive solution to it. Because in this, there is beauty. In this, there is truth. In this, there is flexibility. In this, there is power. Okay?
You're pretty zen about it.
Okay.